Graphene is a unique nanoscale form of carbon that is disrupting legacy materials, bringing step-change improvements in performance across a wide range of industrial and consumer applications. From energy storage and electronics to everyday materials, graphene enables products that are better, stronger, and lighter, while increasing durability and improving sustainability. Graphene is leading the era of new advanced materials.
The following is a presentation that was given as part of a 2-day virtual Graphene Investors Conference, hosted by the Graphene Council.
Well, thank you, Terrence, and thanks to you and the Graphene Council for creating this event. Thrilled to be with you here today and to talk about Graphene DX. Of course, legal disclaimer, this presentation does not constitute an offer to sell or a solicitation of an offer to buy any securities by any person. If there's interest, of course, reach out to me and we'll get this done through proper channels. A brief introduction. So my name is Mike Musnotz, CEO of Graphene DX. My background is in clinical microbiology and infectious disease. I spent my career in the diagnostics industry, bringing transformational technology to change patient management at the point of care at companies like Binax and Alere and Cepheid, which we sold to Danaher. I joined Graphene DX about 1.5 years ago because of the incredible ability for it to transform patient care and diagnostics. Our chairman is Namal Nawana. He was known for being CEO of Alere, who sold it to Abbott for $8 billion, went on to lead the global medical device company Smith & Nephew, and more recently created a platform called Saphros to transform consumer and point-of-care diagnostics. And the link here is that Namal is the chairman of Saphros, also the chairman here at Graphene DX, and has been an angel investor for about 7 years. Saphros has a minority equity stake in our company. I'll talk about what that looks like in just a moment. And then our technical leadership is Dr. Trevor Morin. Trevor has a very relevant background in biochemistry, but also he was the founder and CSO of a company called Ontera, formerly known as Two Poor Guys, that used solid-state biosensors to do next-generation sequencing. So what do we have? If you're able to see on my video, at the tip of my finger is our biosensor. We are taking a silicon wafer patterned with electrodes, applying a monolayer of graphene and turning it into a field effect transistor effectively. And what we bring is lab quality accuracy in the palm of your hand in only 3 to 5 minutes. And when I say it's a platform, I truly mean it's a platform in that we can detect nucleic acids, we can detect proteins and small molecules, and we can do so from a variety of different sample types. So ranging from swabs to stool to urine and even whole blood. And what's remarkable is that we're able to detect disease states from these samples without doing sample preparation in most cases. Now, our first product will be a urine-based test for sexually transmitted infections, chlamydia and gonorrhea. Now, what's interesting about our form factor, if you can see here in front of me, is we are a single-use disposable, meaning we don't have an instrument, we don't have a reader, and that's really important as we think about making this technology accessible to all and scaling very rapidly. And then importantly, the ability to do multiplexing, meaning a single sensor from a single patient sample can detect up to 32 different analytes, brings real power for things like a syndromic respiratory panel, where you may want to look for flu and RSV, COVID, common cold, and many other causative agents. Our economics we'll talk about in a moment, but we have line of sight to very low cost of goods. We have a contract manufacturer established and commercial channels in place. All of this backed by a very deep and broad IP estate. So I mentioned our connection to Saphros. We're based in Boston. We sublease space from Saphros, and we have some G&A leverage as well, meaning that Saphros provides back office functions like legal and HR. I get a cross charge, but I access really top quality industry veterans. But more importantly, the leverage I get from Saphros is they act as my contract manufacturer. I'm using their existing manufacturing capacity. I've designed our disposable to go directly onto their manufacturing line, bringing down my cost of goods and reducing the amount of capital I need to get this product into the market. And then importantly, from a commercial standpoint, Saphros has sales channels into the point of care, as well as to the consumer for diagnostic testing, and they are a non-exclusive channel partner for me in the US, meaning I don't need to build as large of a commercial team to have an impact and bring this test to the masses. So in case you couldn't see the device in my hand, here's a picture as well as a drawing. At the heart of it, of course, is our graphene biosensor. We have a thermoformed plastic shell. We're not using injection molding, and that saves us time and money. And then you see the electronics. This thing is completely integrated with an e-ink Kindle type display, a rigid PCB. It's powered by a 3-volt coin cell battery and has all the processing on board to be able to process the sample, interpret results, and read out a very clear chlamydia or no chlamydia, gonorrhea or no gonorrhea. Additionally, we have an NFC chipset so that we can communicate to a smartphone or tablet to interface with the electronic medical record if necessary. Now, this device shown on the screen is specifically designed to handle urine as a sample type. We have additional drawings and even IP for other devices that are similar in shape for swabs, saliva, and even blood. So our whole premise is that we want to bring the right answer closer to the patient more quickly. If you think about STI testing today, chlamydia and gonorrhea testing, you collect a sample at a doctor's office, you ship it to a lab, and you wait days for a result. Now, more recently, some people have innovated by bringing the testing equipment into the clinic, but the fastest one is still 30 minutes, and no doctor in the US or in most settings will spend 30 minutes with a patient. That means you have a risk of loss to follow-up where you can't track down that patient, or even if you can track them down, you're placing an operational burden on the clinic staff to go chase down patients. With us, we have the doctor, the patient, and the correct result all together within 5 minutes. Better for the patient, you can treat or counsel as necessary and prevent onward transmission of the disease. So I love this presentation because I don't have to explain what is graphene. You all know it well. Terrence did a wonderful job of providing an overview, but here's what we're doing. We're creating a field effect transistor. The cartoon on the right shows our silicon wafer patterned with electrodes. And in this case, we're attaching antibodies for COVID to its surface. And when there's a binding event of the COVID virus to the COVID antibody, it changes the conductivity of the material, and that's what we measure. And so on the next slide, you'll see what the output looks like. And on the left, you have our transfer curve or an IV curve. The lowest point or the minima is the Dirac point. And to the naked eye, you can see when there's a binding event. So the blue dashed line is when buffer is introduced to the sensor. You add a patient sample with the target, and immediately there's a pronounced shift to the left of this Dirac point. That's one thing that we measure. It's something that you can see with your naked eye. We actually measured 29 different metrics on this IV curve, apply some light signal processing, and that helps us not only with QC of incoming material, but making the correct patient call in the field. So I mentioned up front that this is a versatile and really powerful platform. Here's just a collection of proof of concept showing that we can detect chlamydia, of course, COVID, endogenous proteins like hemoglobin, concussion markers like GFAP, and many other things, including small molecules like drugs of abuse. And we do this with a very good sensitivity, a limit of detection that's orders of magnitude better than lateral flow tests. But the real proof is in the pudding, as they say, and what happens when you test patient samples. That's exactly what we did here. We did this with an unoptimized sensor, testing 28 patient samples. These were urine samples put directly onto the sensor with no sample preparation. We compared to the Hologic Panther. That platform is a nucleic acid amplification test that's one of the most sensitive that's used in the central laboratory. And so for the 17 patients that were positive on Hologic, we detected 15 of those for 88% sensitivity. On the flip side, there were 11 patients negative, and we called those perfectly correct in 11 out of 11 cases for 100% specificity. Now, if you look a little closer at those two positives that we missed, we then performed a PCR in-house, and it had a cycle threshold value of 37 in one case and greater than 40. What that means is there was very, very low bacterial load in the sample, and so those that we missed were really challenged samples. Since this time, we've optimized the antibody selection, we've optimized our manufacturing process, and now we're prospectively enrolling patients to get a larger sample size and show that we can improve the sensitivity from this already impressive point. And so when I think about who are those players who are bringing STI testing into the doctor's office or into urgent care, it's folks like Cepheid and Binks. You see here from the picture, they have expensive and cumbersome instruments, or Visby Medical, which has a single-use disposable. Two key differentiated factors for us. First one is important, it's time to results. 3 to 5 minutes for our test compared to 28 minutes or more for the others. Again, we fit into that patient and doctor interaction timeframe. Secondly, we have line of sight to very low cost of goods, $5 for this fully integrated single-use disposable. That's a fraction of the cost of these other products. And what that means is, especially in the US healthcare system, we have room for us to make healthy profits, to incentivize the channel partners, and actually provide economic incentive for the doctors to provide faster and better care for their patients. So everyone in the supply chain wins. And with the reimbursement situation in the US, there's a real economic incentive for the doctor to do this in the clinic. So our market that we're addressing, this is the in vitro diagnostics or IVD market. It's a $100 billion market excluding COVID, because after all, that's difficult to characterize, it's difficult to predict in the future. So the core IVD market's about $100 billion, growing to $120 billion. And we're targeting those two subsegments that are the fastest growing, that being point of care and the consumer. And I mentioned that our first application is for chlamydia and gonorrhea. So this is a US-centric view. The US market's the largest for this particular disease state. And let me walk you through the pie, right? The dark blue section is send-out testing to a laboratory. 5 years ago, this pie would have been entirely blue, but there is a move afoot to take testing out of the laboratory and closer to the patient. Folks like Cepheid, Visby, and Binks have now done about 11 million tests per year, decentralized, and that is growing. We think we can actually help accelerate that shift that's already underway because we're addressing cost and we're addressing time to results. And then there's a small group of folks like Everlywell and Let's Get Checked that do home collection. And if you're not familiar with their business model, they will send you a urine cup to your house, you mail it to their laboratory, several days later, they give you the results. And I actually don't view these folks as competitors. Rather, I think they're playing an important function to educate patients and the marketplace that you can get STI results in the privacy and comfort of your own home. In the future, we'll bring the device with the answer to the home, not just a urine collection cup. So as we think about our go-to-market strategy, I've grown up in this industry. I've brought significant transformational technology into these same subsegments of point of care. I've done it actually at Cepheid with their instrument, and we know where to target, where the unmet need is greatest. And these are segments like Planned Parenthood, public health departments, university health, urgent care, and even emergency departments. We have relationships that go back 2 decades from my personal experience driving real value with people like McKesson and Henry Schein. And through Sapphiros and our own relationships, we're going to have access to all of these customers, including the 100,000 plus doctors' offices that are targets for this test and future tests that we're going to be developing. When we get to the home, sorry, could you go back 1 second? Thank you. When we get into the home market, Sapphiros today is selling products through Walmart.com and Amazon, and we'll be leveraging those same channels. Now, on our regulatory strategy, we're already engaged with FDA through their pre-submission process, where we're aligning on our clinical study design. On a reimbursement standpoint, there are 2 existing CPT codes that provide $60 reimbursement for this test. So cost of $5, margin for us, margin for the channel partner, and the doctor makes money by buying the test and running it on their patients. In the future, we can actually apply for a bespoke or custom CPT code that has the potential to reimburse even higher. And the fact here is between our team and the Sapphiros team, we have experience with these channel partners and bringing transformational products to the market.
Mike,
so our product pipeline.
We're at 1 minute.
You got it. Thank you. Our product pipeline. This is a platform. We're focused solely on getting our chlamydia gonorrhea test to the market. It will be followed by respiratory products and other potential products in the future. It's a function of how much capital we bring in, how quickly we can go, and how many teams we can have develop assays in parallel. And so what I would say is we have a $20 to $25 million Series B. We're actively working on building the syndicate. We have a lead investor identified, term sheet in hand, and about 16 million in committed capital. We have really transformational technology that harnesses the power of graphene. And if anyone has further interest, would love to talk to you under NDA and share more about our company and where we're going. So Terrence, thank you for the opportunity, and thanks everyone for your interest in Graphene DX.
For more information on market opportunities and to connect with experts, contact the Graphene Council at thegrathenecouncil.org.